Wetland ecosystems lie in the transition zone between land and open water, and they therefore have characteristics of both aquatic and terrestrial ecosystems. Wetlands have three key components: hydrology, the physico-chemical environment, and biota, and these components are closely linked. For example, changes in water level affect the redox chemistry of the sediments, and the biota is affected by their degree of tolerance to changing water and chemical conditions. Wetland plants can alter water flow and inundation by modifying topography, and plant roots can release oxygen, altering redox conditions in the sediments. Wetlands may be classified into 6 broad categories: riverine, including floodplains, lake wetlands with standing waters, marshes with mineral soils, peatlands, often with sphagnum mosses, coastal wetlands, and human-made wetlands for multiple uses. Wetlands are found throughout the world, and they are especially abundant at high northern latitudes. The global wetland area is estimated to be around 12 million square kilometers, and many of these areas are seasonally inundated by floodwaters. These fluctuating water levels greatly affect wetland microbial processes and the associated biogeochemical cycles. When the water table rises, oxygen is depleted, and the sediment becomes subject to anaerobic conditions. Various electron acceptors may then be used successively as the redox potential decreases. When the potential drops below 250 millivolts, nitrate becomes the main electron acceptor and is reduced to gaseous N2. This removal of nitrogen is an important water purifying function of wetlands. At lower potentials, oxidized forms of manganese and iron are the electron acceptors, followed by sulfate. Under anaerobic conditions, at the lowest potentials, CO2 and methylated compounds are converted to CH4 by methanogenesis. Wetlands strongly interact with the atmosphere, including via the uptake of CO2 by photosynthesis, and the release of CO2, carbon dioxide, and CH4, methane, by microbial decomposition processes. Wetlands provide many ecosystem services: regulating, such as flood and nutrient control, provisioning, such as food and fresh water, cultural, such as recreational, and supporting services such as biodiversity, soil formation, and nutrient cycling. Yet despite these many important functions, wetlands are in decline throughout the world. The main drivers for this decline are drainage and conversion, excavation of peatlands, conversion of mangrove forests, and biological invasions. Ongoing climate change is another major threat to wetland ecosystems. Vegetation shifts are likely with the changes in temperature and in precipitation, with both positive and negative effects on carbon storage. In Arctic and subarctic wetlands, as shown here, thawing permafrost is resulting in increased greenhouse gas emissions. Given the importance of wetlands and the increasing threats that these ecosystems are exposed to, a number of international and national efforts have been undertaken to promote their conservation, protection, and management. At the international level, the Convention on Wetlands was signed in the Iranian city of Ramsar in 1971. The mission of the Ramsar Convention is the conservation and wise use of all wetlands through local and national actions and international cooperation. This intergovernmental treaty now has over 170 contracting parties, and it recognizes more than 2,400 wetlands of international importance. Throughout the world, major efforts at a local scale are now being made towards restoring and protecting wetlands. One such example is Changshu, located in the southeast of China. Professor Shuqing An is director of the Institute of Wetland Ecology at Nanjing University, and he and his institute have worked for many years on restoration and conservation strategies for the Changshu wetlands.
A key aspect of the Changshu wetland restoration strategy was a comprehensive multi-level wetland conservation system. This included national wetland parks, provincial wetland parks, and wetland conservation areas, as well as zones for food production and urban development. In 2018, Changshu was among the first cities in the world to receive accreditation under the Lausanne Convention as a wetland city.
Changshu is now a model for conservation and wise use of wetlands and their resources. Another example of successful restoration is the Room for the River program in the Netherlands. This was launched by the Netherlands government in 2006 in response to severe flooding problems. It encompassed 37 projects in which the embankments and the active floodplains were excavated to a lower level, and secondary channels were created. In addition, the levees were repositioned to increase the area of regularly flooded floodplains and to lower the flood level. This greatly increased the capacity for effective river discharge, and now protects more than 4 million people from flood risks. In addition, the Room for the River program has had major ecological benefits, as described here by Dr. Jos Verhoeven, Emeritus Professor of Landscape Ecology at Utrecht University.
The program was completed in 2019 and has resulted in a massive increase in the biodiversity of the floodplain areas. Many species that were almost lost to extinction have returned. In addition, the natural functioning of the river floodplain connections has been restored, and this has contributed to landscape attractiveness and environmental health.
A third and final example of wetland restoration is in Everglades National Park in Florida, USA. This lies in a transitional bioclimatic zone between subtropical and tropical regions. The park is best known for its mangroves, sawgrass prairies, and freshwater wetlands that draw water from Lake Okeechobee, the liquid heart of the Everglades. Over the past decades, the lake and its watershed have been subjected to large increases in nutrients, especially phosphorus and nitrogen from agricultural and urban activities. As part of a comprehensive restoration plan, stormwater treatment areas have been established over large parcels of land. These are constructed wetlands that remove and assimilate nutrients through plant growth and can result in an 80% reduction in external phosphorus loading. These three examples of wetland restoration highlight the need to pay close attention to water flow and to water quality, and they underscore the immense ecological and societal value of wetland ecosystems.